Welcome. There is a problem at your screen. I think इस प्रॉब्लम को सॉल्व करने के लिए हमें एक आइडिया की ज़रूरत पड़ेगी जो अभी तक मैंने डिस्कस नहीं किया है. दैट इज़ कॉल्ड इम्पल्स मोमेंटम and we have to be careful. But what is the problem? As you can see at your screen, two identical balls can rotate freely on a weightless rigid rod. Okay, about a horizontal axis O. This is fine. This is the horizontal axis. Passing through its middle, a third identical ball falling vertically collides elastically with the right ball. Okay, I can see that the velocity of the impacting ball is v. Okay, the line joining through the centers of the balls at the moment of impact is inclined to an angle of 45 degree with the vertical. Oh, बॉल की वेलोसिटी ऐसी है बट वो इम्पैक्ट जो कर रहा वहाँ पर राइट. दिस इज द वेलोसिटी. शुड आई राइट दिस v नॉट because that will be fine. Initial velocity. और क्या है ये velocity of impacting ball is v naught I can say, and the line passing through the centers of the ball at the moment of impact is inclined at an angle of 45 degree with the vertical. Okay. जिस मोमेंट पर इम्पैक्ट हो रहा है उस मोमेंट पर दोनों के सेंटर्स को मिलाने वाला जो लाइन है वो वर्टिकल के साथ 45 डिग्री का एंगल बना रहा है. दैट्स फाइन. Find the velocity of the impacting ball after the impact if before the collision the balls were at rest. ये दोनों balls, those were at rest, because third was not, because it was already hitting the right ball with velocity v naught, about which all the description is given on the rod, and the rod was located horizontally. Okay, the radii of the balls are small compared to the length of the rod. This is right. So the collision is elastic. क्योंकि मैं अभी भी मान लेता हूँ, मैंने पहले वाली वेलोसिटी को भी नॉट मान लिया था. सो आई एम गोइंग टू कॉल इट भी. राइट. सो अब क्या होगा? What is going to happen next? This is the main problem. Because before writing any conservation equation or anything, impulse momentum equation, we have to careful about many things in this problem. Because one is कि ये दोनों के दोनों ये बीच का जो है ना, the rod is light and this is going to create problems. So I'm going to make a picture like this. And if I'm going to draw this picture, okay, fine it is. Fine it is. Okay, fine. And here is the axis at the middle of the rod. Okay. एंड प्रॉब्लम ये है कि एक और बॉल भी है यहाँ पर and it's going to impact. Identical balls, they are not looking identical but they are identical. This right ball and this ball is identical, and I'm not going to change the figure because it will cost me lots of time and lots of effort. So but I can do something. This angle is 45 degree. I can see here. So दोनों identical balls हैं and this would be treated like points, no problem at all. इसकी velocity collision के बाद ऐसे है v, वो मैंने मान लिया, और before the collision इसी की velocity v naught थी. इस पर जो फोर्स लगता है कॉलिजन के दौरान, ये चूँकि लाइन ऑफ इम्पैक्ट के अलॉन्ग, तो इस बॉल पर जो फोर्स लगेगा, द फोर्स एक्टिंग ऑन द बॉल, द इम्पैक्टिंग बॉल, it will be in this direction, I know for sure. So it's going to hit this ball. Newton's third law of motion, इतना तो मैं कर ही सकता हूँ. That force is going to be this right ball. इतना तो है, but वो जो right ball है उस पर एक force और भी लगेगा. Someone else is going to exert a force on it, and that is the rod. Rod is going to exert the force on both the balls. And what is going to happen? I think the rod is rigid. It's weightless, but it is rigid. That means it can provide this ball the velocity in this direction only. मैं इस velocity को u मान लेता हूँ, right? This is not the potential energy. This is the velocity u. And so I know कि since the rod is rigid, so इस बॉल को भी collision के बाद जो velocity मिलेगी, that is going to be u in this direction. And so I have decided the directions of velocities. I'm sorry about this. So I can write at least, since the impact is elastic, I can write the conservation of energy first, conservation of kinetic energy, and that will be velocities. क्या क्या है, एनर्जी में डायरेक्शन और एक्शन की ज़रूरत तो है, पड़ेगी नहीं, तो that is half mu square multiplied by 2 because दोनों को मिलती है ये स्पीड. And after the collision, the velocity of this thing is half m. Mass तो सबके same है, mass mv square, and the initial kinetic energy was only half m v naught square. So this is my equation number 1. Or if you want to remove all those things, you can write like 2. This will become simply 2u square, as you can see here, plus b square equals v naught square. Make it equation number 1. You remove it. This is equation number 1. And but the forces acting on this ball is still not clear. But I can see one thing. I'm now going to use the impulse momentum theorem. So gravity, force of gravity is out from my consideration. This is never an impulsive force because it cannot change its velocity abruptly. So if I'm going to consider the impulse momentum theorem, and this is the case of the impact, well, we have the case of an impact at hand. So I'm going to consider only the impulsive forces, and gravity is not the impulsive force. This force F is impulsive, no doubt, and some other force that the rod is going to exert on balls, because rod can only exert on balls those impulsive forces, those are going to be impulsive as well, but not the gravity. So forget about gravity. So this momentum to this ball has been provided by the impulsive force, by an impulsive force. So the impulsive force provided this ball, this left hand ball, and a momentum in vertically upward direction. That means the force acting on this by the rod, because nobody can provide except the rod, at least to the left ball. So there must be an impulsive force F naught. I said it F naught in this direction. इसको अगर F naught force दिखाया तो what do you think कि इस पर कैसे फोर्स लगाया होगा बॉल ने? I don't know. I have to think about this rod itself. नहीं, रॉड ने उसको उधर impulsive force लगाया. Rod exerted an impulsive force on this left wall in this direction, vertically upward direction. But how did the ball exert the force on the right ball? I don't know. So I'm going to draw a diagram again, and I'm going to think about the not about the balls. I'm going to think about the rod itself. So remove the balls. I'm going to think about the rod. Rod is rigid, I know, and it is weightless. Weightless means what? Weightless means this rod can rotate, but its moment of inertia is certainly zero because it has got no mass. So it will have some acceleration because its angular velocity is changing. So it will have an acceleration. I don't know what, but acceleration is certainly not zero. But we all know torque equals I alpha. That means alpha is equal to torque upon I, and the moment of inertia of this is zero because it rod is massless, so इसका moment of inertia zero होगा. What about the torque? If then there is only one condition, torque should be also equal to zero. Yeah, that's true. And for the torque to be zero, since this rod exerted a force on the left ball in vertically upward direction, according to the Newton's third law of motion, the left ball is going to exert a force F naught on the ball. So the right ball should exert the same force F naught. It's the middle. It's in the middle. The axis of rotation is in the middle. So the right hand ball must exert the force F naught in vertically downward direction as well to make the torque equal to zero. Because there is some alpha and moment of inertia in zero, that can be possible only in the case when torque is also acting on the rod equal to zero. That means मुझे पता चल गया. I know now कि what are the forces acting on this ball and this ball by the rod. ये तो मैंने दिखा दिया. लेफ्ट वाले बॉल पर तो I have already shown it. Right side on the ball, the force is going to be F naught as well, because it has exerted a force F naught on the rod in vertically downward direction. So rod will exert the same force in vertically upward direction on the ball. So I have shown all the forces, right? It was tricky, but it is right. So I'm going to write down the write down the impulse momentum theorem for all those things. And may I choose a coordinate frame simply as x and y axis, because this I'm talking about I'm not talking about the rotation of the rod, rather than I'm talking about the translation of the balls. So ball on the left, I should write the impulse momentum theorem simply as F naught delta t dt I should take, or delta t, that's also fine, equal to mass into momentum gained by it. This is equation number 2, because I have already equation number 1. This was u, and I can write the impulse momentum for the right block. तो इसका momentum किस direction में? Finally it get the momentum in vertically downward direction. So I'm going to write the impulse momentum theorem for this is finally the final impulse is initially it was at rest. So its final momentum is simply mu, and the forces impacting on it are the component of this force. I suppose this angle was 45 degree. It was given. So this is F cos 45. That means F cos 45, that is 1 by root 2 minus, there was also a force acting in vertically upward direction, F naught. So F naught is also an impulsive force. So these forces multiplied by delta t. This is the equation number 3. And what about this ball, the impacting ball? 45 डिग्री आई हैव ओके. सो एक्स कंपोनेंट के बारे में और वाई कंपोनेंट के बारे में भी मैं बाद में लिख दूंगा. आई एम गोइंग टू राइट फर्स्ट द एक्स कंपोनेंट ऑफ द इम्पल्स एक्टिंग ऑन इट. एंड फॉर इम्पैक्टिंग बॉल आई शुड राइट f of cos 45 or sin 45 degree delta t. This is the only impulse acting on the impacting ball, and that will be equal to mass into x component of its velocity. This is equation number 4. And I'm going again, and I should write again the impulse momentum theorem along the y-axis. And what is it? Y-axis. It finally have some velocity in this direction. The angles are 45, so I don't care. I don't know, but I can simply write its momentum, its change in momentum, because it has got some initial velocity v naught in this direction, as you can see here. So change in momentum of this impacting ball along y-axis is going to be I would first like to write the change in momentum, that is mvy minus mv naught change in momentum, that is equal to the force acting on it, the impulsive force acting on it in this direction. So there will be the y component of force, and I have taken y-axis in downward direction, so I am going to write the impulse of this force as minus f sine 45 or cos 45, that is 1 by root 2 delta t. This is the equation number 5. And go and solve them all. How can you do this? You can do this, and you need to find out velocity of the impacting ball after the impact is going. You need to find this velocity equal to under root 17 by 5 v naught. This should be your answer. Anything else will be wrong. Thank you very much for watching.